So in this section, we're going to understand what an ordered pair is. Usually, we define an ordered pair as a composition of the x-coordinate, also known as the abscissa, and the y-coordinate, also known as the ordinate. And it has to be written in a fixed order within a bracket. So usually ordered pairs are written as the abscissa and the ordinate value. Now let's understand what's an abscissa and an ordinate. So before that, what's the use of an ordered pair? Actually, the main use of an ordered pair is this: it helps us to locate a point on the Cartesian plane. So this is our Cartesian plane, a plane that consists of an x-axis and an y-axis. So whenever we have any point, let's say this is a particular point, so we can locate this point on the Cartesian plane. Then the numeric value associated with this point is going to be some real numbers, and that is going to help us exactly pinpoint its location with respect to the origin. Origin is the point where the x-axis and y-axis intersect. Now it consists of two parts, the abscissae and the ordinate. The abscissa is what is referred to as the x value of the point, and the ordinate is referred to as the y value of the point. For instance, let us plot the point P with coordinate value 4, 3. So let's say we have 1 unit, 2, 3, and 4. So this is a 4 unit. So what we do, we first move 4 units to the right, starting from the origin. So the moment we reach the point where it's 4 units from the origin, from there let's start moving upwards 3 units. So we'll move 3 units, 1, 2, 3. So this gives us the location of a point, let's call it A, which is 4 units from the origin, from the y-axis, and it is at a distance of 3 units from the x-axis. So this particular point 4, 3 is written in a very specific manner. So the order is very important here, meaning that we always specify the x value, so the distance of the point A from the origin when measured along the x-axis. That is what we have to specify first, and then we specify the ordinate, which gives us the location of the point O from the x-axis, or we could say the y distance away from the x-axis. Now different points are going to have different values. For instance, if we are to plot the point 1 and 2, so that would mean we have to first walk 1 unit along the positive x-axis, and then let's say we move 2 units along the positive y direction. So that would give us the coordinate value 1, 2. So let this be another point B. So this point A is represented by the value 4, 3, whereas point B is represented by the value 1, 2. So these are called ordered pairs. So this is how we represent an ordered pair in a Cartesian plane. So let's take a general example. For example, let's say we have an ordered pair A given by, let's say, A1, B1. So this means that its abscissa value is A1 and its ordinate value is B1 for the particular point A. Let's consider another point B, such that this one's abscissa value is A2 and its ordinate value is B2. Now we'll talk about the equality of ordered pairs. Equality of ordered pairs what does it mean? This means that the 2 points A and B, suppose the 2 points coincide, that A point is equals to B, so that will say that the coordinate points A1, B1 is going to be equals to A2, B2. So this simply means that the A1 value, that the abscissa of the first point A is equals to the abscissa of the second point B. and the ordinate of the first point A is equals to the ordinate of the second point B. So this is what we mean by equality of ordered pairs. So let us do one quick example. So let's say we have example number 1. Let's say we have a ordinate point, co-abscissor point given by thrice x minus 2, and its ordinate value is 3. And let's say this value is equals to another coordinate point whose value is 2x minus 1, and the ordinate value is y plus 3. So using this information, we have to find the value of x and y. So as it is mentioned that these two ordered pairs are equal, so that means their corresponding abscissor values and the ordinate values must be equal. So we can equate 3x minus 2 to 2x minus 1. Solving this algebraic equation, we have thrice x minus twice x is equals to 2 minus 1. So that will give us x is equals to 1. So we have the x value is equals to 1. And then for the second equation, what we do is we equate the ordinate, the corresponding ordinate value. So that gives us y plus 3 equals to 3. Solving for y, we get y equals to 0. Now let us substitute this value of x and y back to our original equation. So we have 3 times x, which is 1. So 3 times 1 minus 2, comma 3 is equals to 2 times 1 minus 1 is equals to 0 plus 3. So 3 times 1 is 3, 3 minus 2 gives us 1. So 1 comma 3 is equals to 2 times 1 is 2, so 2 minus 1 gives us 1, and 0 plus 3 is simply 3. So we see that x and y are specific values here which are going to make this two ordered pair equal to each other. So this is what is meant by equality of ordered pairs. Let us do a few more problems. So in this question we have the ordered pair x over 3 plus 1 and y minus 2 over 3 is equals to the ordered pair 5 over 3 comma 1 over 3. So using this information we have to find the value of x and y. So let us begin. Since the two ordered pairs are equal to each other, so that means their corresponding abscissor values and the corresponding ordinate values must be equal. So the abscissor of the first ordered pair is x over 3 plus 1, which must be equals to the abscissor of the second ordered pair, means the ordered pair on the right hand side. So that gives us x over 3 plus 1 is equals to 5 over 3. Similarly, we can say that the ordinate of the ordered pair on the left hand side, which is y minus 2 over 3, must be equals to the ordinate on the right hand side, which is 1/3. So let us solve these two equations. So x over 3 will be equals to 5 over 3 minus 1. So that gives us x over 3 is equals to, so 5 over 3 minus 1 will be 2 over 3. So solving for x, we get x is equals to 2. Then in order to solve this second equation for the value of y, so we take 2/3 to the right hand side, so that will become positive. So we have 2/3 plus 1/3, which gives us y is equals to 3 over 3, which is simply equals to 1. So this is going to be the value of x and y. X is equals to 2 and y is equals to 1. So anyways, we can go ahead and substitute the value of 2 into our given equations on the left hand side. So we have x is 2, so 2 over 3 plus 1, which is 5/3. So that is equals to the abscissor of the right hand side. Then we can substitute for y by 1. Then 1 minus 2 over 3 is going to give us 1/3, which is equals to the ordinate of the ordered pair on the right hand side. So this is how we find the value of x and y using equality of ordered pairs. Let's do another problem. So we have another two coordinate pair ordered pairs which are equal to each other, and then we have to find the value of a and b. So we begin by equating the corresponding abscissa and the ordinate value. So we have a plus 1 equals to 3. So solving for a, that gives us 3 minus 1. So a will be equals to 2. And then we equate the ordinate values. So we have b minus 2 is equals to 1. So that gives us b is equals to 2 plus 1. So we have b is equals to 3. So we can substitute the value of a and b. So we have 2 plus 1 comma 1 is equals to 3 comma b is 3. So 3 minus 2. So that gives us 2 plus 1 is 3 comma 1. And on the right hand side we have 3 comma 3 minus 2, which is 1. So these are the values of a and b.